Good morning, all of you. In the last class, we have already discussed about two properties of integers. The first one was closure under addition, and the second one was closure under subtraction. And today in this class, we will be discussing the third property, which is commutative property of integers. Okay, so what do you mean by commutative property? For any two integers a and b, a plus b equal to b plus a. That is the commutative property. That is, for any two integers a and b, a plus b equal to b plus a. That is commutative property. So in order to check this commutative property, let's take any two integers. Suppose I am taking integers as 5 and minus 2. Okay, 5 and minus 2, that is a equal to 5 and b equal to minus 2, such that I am adding these two integers, that is 5 plus minus 2. What is 5 plus minus 2? You already know that when you are adding any two integers having different signs, then you have to just subtract them and put the sign of the bigger number. So here what is 5 minus 2? It is 3, and what is the sign of the bigger number? Plus. So plus 3. So what is 5 plus minus 2? It is plus 3. So now we are done with a plus b. Now let's see what is b plus a. So here what will be b plus a? B plus a means what? Here b is minus 2 plus a means what? 5. What is minus 2 plus 5? Again you can see that when you are adding integers of different sign, then you have to just subtract them, that is 5 minus 2 equal to 3, and put the sign of bigger number, that is plus 3. Okay, when you have added a plus b, you got plus 3, that is 5 plus minus 2. Then again when you are added minus 2 and 5, that is minus 2 plus 5, that is b plus a, you got the same answer 3. So you can say that a plus b equal to b plus a, that is the commutative property. And you can prove this commutative property using any integers. Actually this is commutative property for addition. Okay, so from this we understood that addition is commutative for integers. Okay, addition is commutative. Now let's see what is the case of subtraction, that is a minus b. What happens when you are doing a minus b? Let's take the same example itself, that is 5 minus 2. You already know that when you are adding subtracting any two integers, then what you have to do, you have to just add with the additive inverse of the second number, that is 5 plus, what is the additive inverse of minus 2? It is 2, that is 5 plus 2 equal to 7. Now let's see what is b minus a. This one is a minus b. Now b minus a. What is b minus a? Minus 2. b is minus 2 here, minus a is 5 here. Okay, so b minus a is minus 2 minus 5. What is that? Minus 2 plus, what is the additive inverse of 5? It is minus 5. Now what is minus 2 plus 5? When you are adding integers having the same sign, then you have to just add them and put the sign, that is 2 plus 5 is 7, and what is the sign? Minus. So minus 7. So in the first case when you are doing a plus b, you got 7, but when you are doing a minus b, you are getting 7, and when you are doing b minus a, you are getting what? Minus 7. That means a minus b is not equal to b minus a, isn't it? So you can say that subtraction is not commutative for integers. Got it? In the first case when you were doing a plus b, you got a plus b equal to b plus a. That means addition is commutative for integers. But in the second case, when you have done this a minus b, then you got that a minus b is not equal to b minus a. That means subtraction is not commutative for integers. So that's all about the commutative property. You can do this by taking any examples. Now let's do some examples given in your textbook, page number 2, and prove this commutative property. The first example, as you can see, it is minus 8 and minus 9. So first you have to see a plus b, or minus 8 plus minus 9. So what is minus 8 plus minus 9? You are adding integers having the same sign, then you have to just add them and put the sign, that is 17. What is the sign here? Minus. So minus 17. Okay. So this is what? A plus b. Now let's see b plus a. B plus a means what? Minus 9 plus minus 8. You have to just add them. Here also you can see that you will get minus 17 itself. Okay, so you can say addition is commutative for integers. Now let's see what is the case if we are doing the subtraction, that is a minus b. A minus b means what? Minus 8 minus minus 9. You know that when you are subtracting, you have to just add with the additive inverse, that is minus 8 plus, what is additive inverse of minus 9? It's 9. So what you will get? Minus 8 plus 9, 1. That is, you have to subtract and put the sign of bigger number, that is 1. Now let's see b minus a. What is b minus a? Minus 9 minus minus 8. What is minus 9 minus minus 8? Minus 9 plus additive inverse of minus 8 is 8. So what is minus 9 plus 8? You have to subtract them and put the sign of bigger number. So minus 1. So in the first case a minus b, you got a 1, and in the second case b minus a, you got minus 1. So both are different. That means subtraction is not commutative for integers. So we have proved this commutative property using these two numbers. Now you can do the remaining 2 and 3 questions by your own and check this commutative property. Okay, so that's all for the commutative property. I hope all of you understood this. Okay, thank you.